Hello everyone, my name is Paul Worsfold and I'm going to talk to you today about how we use sports biomechanics to understand and optimize running shoes. So when we consider how humans run, about 80% of us will contact the ground with our heels first. So in biomechanics, if we were to use a force platform, for example, to measure the forces created during the running phase, we would see a trace similar to this. So we have a heel contact, an initial peak called our impact peak. And secondly, as we roll the foot over and start to push ourselves away, we get a second peak called the propulsive peak. Now, the two sides of the graph are quite different in terms of how we understand and how we develop running shoes. So one side of the graph, the impact peak, is much more to do with injury prevention and trying to reduce those impact peaks as best we can. In contrast, the second phase of the graph, around the propulsive side, we're much more interested in trying to increase that force to propel our athletes further and faster away as they run. We also need to consider, in terms of biomechanics and injury prevention, something called loading rate, and that's the time it takes for force to transfer from the contact phase to the peak itself. The faster that is, the greater chance there is for injury. So we, as biomechanists and shoe manufacturers, try and minimize and slow that rate of load down as best we can. And we've seen over recent years quite a change in footwear design in terms of running shoes and the effect those shoes have on how we run, but also the forces that we produce when we're running in those types of footwear. So from traditional shoes where we have those two peaks, the impact peak and the propulsive peak, whereas move down more into minimalist shoes and barefoot technology where we actually start to reduce that initial peak because we start to run less so on the heel of the foot and more so on the forefoot. Interestingly, and more recently, we've seen this big trend and shift in terms of performance shoes, such as the Nike Vaporfly, where we've seen significant differences in terms of performance. And biomechanically, the effect of that isn't necessarily to do with the impact or loading rates, it's more to do with the propulsive phase of energy storage and return. And that's achieved in these types of shoes by using some form of carbon plate that helps to store that energy as we make contact with the ground and then release it in the right direction at the right time. And we've seen significant improvements in performance because of that.